This is part 1 of lesson 7.4. Today we're going to talk about the properties of rectangles. So a rectangle is a type of parallelogram. So that means it has all of the same properties that a parallelogram does. The opposite sides are congruent, the opposite sides are parallel, the opposite angles are congruent, the consecutive angles are supplementary, and the diagonals bisect each other. But now we have two new properties. All of the angles are right angles in a rectangle, and the diagonals are actually congruent to each other. So we can use that information to solve a problem. So in this picture, we know this whole side is 27. We know this part of the diagonal is 15. And because the diagonals bisect each other, we know those are the same. And because the diagonals are congruent, those are also the same. So every one of those pieces is 15. So AC, the whole length here is 15 plus 15 is 30. BD is the other diagonal, and because the diagonals are congruent, BD is also 30. BE is a portion of the diagonal, so BE is just from B, obviously, to E, from here to here, so that's going to be 15. AB is a side, and AB is the same side as CD, right? They're opposite sides, so they should be congruent, so AB is 27. But now BC. BC, what we're looking for here, is actually part of a bigger right triangle, because all the angles are right angles. So we know this side is what we're missing. This whole side here is 30. And this side's 27. So we're going to have a right triangle. And we can do the Pythagorean theorem to solve. So we know that across from the right angle is our hypotenuse, so that's our C. So these are A and B. So we need to do 27 squared. Seven 29. Let's subtract 729 from both sides. And now we would take the square root of 171, and we get a decimal. We can say 13.1. Which means that BC is 13.1. So you go ahead and try this next one. Pause when you're ready to see the answer, hit play. All right, so again, opposite sides are congruent, so QR is 10, SR is 24. Then SQ, I drew my right triangle here. I had a side of 10, a side of 24. The hypotenuse was C. The hypotenuse is what we were missing. So when I do the Pythagorean theorem, I get 26, which means SQ and PR, because PR is the other diagonal, are both 26. And then QT is half of the length of the diagonal, and half of 26 is 13. All right, next we're going to look at some angles. So we know that each corner is a right angle, so I can mark them as such. And we know the diagonals bisect each other and are congruent. So we actually have a bunch of isosceles triangles here. That angle is 64. And those two angles have to be the same. I can do 180 minus 64. And I get 116, and then divide it by 2 to find each one. So that's 58 degrees for each one of those. So the angles adjacent to them have to add to 90 because all angles are 90 degrees in the picture. And because they're both in isosceles triangles, this is 32. That's 32. And each of those is 58. So if I wanted to find the measure of angle WY, X, WY, I just found 58. If I want Y, X, Z, I just found that one's 32. If I want W, V, Z, so W, V, Z, oh, I didn't find that one. That one's right there. So these are a linear pair. They have to add to 180. So 180 minus 64 is 116. Right, X, W, Z. So X, W, Z is the whole angle up here. That's 90. And X, Z, Y, X, Z, Y, we have 58 there. So you go ahead and try the next one. Pause. When you're ready to see the answers, hit play. All right, so we got the measure of angle MJK was 90 degrees. Measure of angle MJL was 63 degrees because those two added to 90. Angle JLK is alternate interior to that one. That was 63 as well. KML had to add to 90 with the 63, so that's 27. And MNL, this angle here, I found 27 plus 27 plus that angle would equal 180, so I got 126. All right, in our next example, we're given RT and US. We actually want to find VT, just this portion. So let's start by solving for X because we know the diagonals are congruent. We get X equals 8. So if I substitute that back into either of them, that'll give me the length of the whole diagonal. So I'm going to put it into US because that's easier. So we get an entire diagonal length of 26, and VT has to be half of that. So I would get VT is 13. All right, here's another one. VW is this portion right here. SU is the whole thing, which means if I had to find this whole diagonal length of VT, I would be doubling what I have here. So if I double that and set it equal to SU, that would say both diagonals are congruent. So we'll distribute. And now I can solve. So when I get X is 5 and I want WT, WT is the same as VW. So I'm going to put that back in for VW. So we get VW equals 34. All right, you're going to go ahead and try this one. You're given JM, which is this piece here, and MK, which is this piece here. We want to find the whole length of JL. Pause. When you're ready to see the answer, hit play. All right, so those two pieces are equal, so I would set them equal. I get X is 10, so then I actually put it back in for JM. Didn't matter which one, but that was the easier one. So 10 plus 17 is 27, and because JL is double that length, I double the 27 and I get 54. Right, a bit more with angles here. So what we have are alternate interior angles, so I could start by setting those equal. Once I know that X is 2, I'm actually looking for BCE. I'm looking for this angle over here. And I know these two together are a right angle. So if I plug it back into 11x minus 3, I know that that angle and the angle I'm looking for add to 90. So if I subtract it from 90, I get my angle. So I get the measure of angle BCE is 71 degrees. You go ahead and try this next one. Pause. When you're ready to see the answer, hit play. All right, so setting those alternate interior angles equal, you get x is 12. When I plugged it back in for HJI, I got 68 degrees. So if I take that away from 90, measure angle GJK was 32 degrees. All right, almost done. In this last one here that we'll do together, they give us these two angles. I know that together they have to be 90 because all angles are right angles in a rectangle. So I'm going to add these up to 90. Combine my like terms. So we get x is 7, and I'm looking for angle JHI. So this angle over here, which is congruent to this one over here because they're alternate interior. So I'm going to plug it back in to the 3x plus 2. And I get the measure of angle JHI is 23 degrees. So the last one you're going to try, find the measure of angle ADE. So you're looking for this angle here. Pause. When you're ready to see the answer, hit play. All right, so again, I add these two up to 90. I get x is 4, and I'm looking for this angle here, which is the same as the 13x plus 7. So I plugged it in for the 13x plus 7, and I get the measure of angle ADE is 59 degrees. And that is day 1 of section 7.4.